Hi, my name is Madiha Anjum, and here is my buzz card. And today I'm going to be talking about my row reduction project. So give me one moment while I go ahead and share my screen. Okay, so let's go ahead and get started with the problem. So Allison is the owner of Essence Beauty, which is a new makeup brand that recently opened its first flagship store in Buckhead. And as of right now, her makeup line has 4 types of makeup. She has foundation, concealer, solo eyeshadows, and lip gloss. And right now she's trying to generate interest in her brand by putting out samplers. So on her first day, she sold 12 foundation bottles, 8 concealer bottles, 20 solo eyeshadows, and 15 lip glosses, making roughly $133. On the next day, she sold 10 foundation bottles, 6 concealer bottles, 15 solo eyeshadows, and 18 lip glosses, making $108. And then on the third day, she sold 8 foundation bottles, 10 concealer bottles, 12 solo eyeshadows, and 14 lip glosses for a total revenue of $95. So what we want to know is the unit price of these samplers based on the revenues from each day. So what we're going to do is we're going to define our variables where X is equal to the unit price of foundation bottles, Y is equal to the unit price of concealer bottles, Z is equal to the unit price of solo eyeshadows, and W is equal to the unit price of lip glosses. We can then form a system of equations using the number of products that Allison sold of each makeup type and setting that equal to the revenue that she got from that day in order to form 3 equations for this system. We can then take that system of equations and plug it into an augmented matrix that looks as such. What we then are going to do is that we're going to solve this matrix. We're going to convert this matrix into reduced row echelon form to better interpret the solution set. So reduced row echelon form is defined by having all of the characteristics of reduced echelon form, but also including this idea that in a given pivotal column, all other entries should be zeros. We can get these zeros through the process of pivoting, which is an integral part of Gauss-Jordan elimination. And Gauss-Jordan elimination is an algorithm that can be used to solve systems of linear equations, and it relies on the row operations. So to start, I multiplied R1 by a non-zero scalar of 1/12 to create a leading one or pivot, which is one of the row operations. And in step 2 and 3, as you can see, I subtracted multiples of R1 to create zeros in all the other entries of the first pivotal column. Then I shifted down and right to create another pivot in the entry of the second row, second column. I repeated the steps that I mentioned from before until I could no longer create a pivot that was down and right from the previous one so that we can generate the reduced row echelon form as seen here on this slide. And we can take these values from this RREF matrix and draw out the solutions, which have been noted to the right. And if you noticed, the fourth column in the RREF matrix has no pivot, which makes W a free variable. So this means that this system has an infinite number of solutions because W can be theoretically filled in with any value. And we can parameterize our solution from the previous slide as such, setting W equal to T and rewriting the other equations in terms of T. So since this system has only one parameter, T, and 4 variables, we can say that the solution geometrically is a line in R4. We then need to address our restrictions for this problem because price can't be a negative value. X, Y, Z, and W all have to be greater than or equal to 0. So we can take the parameterized equations from before and form inequalities, solving them to determine that in order to prevent negative prices, T has to be greater than or equal to 0 and less than or equal to 11/9. And using that restriction, we can come up with 3 possible values for T, which represents the unit price of lip gloss. So here I've outlined 3 possibilities. Allison selling these lip glosses samples for free at $0, for 50 cents, or for $1. So by plugging in these values for T in the parameterized form of the solution, we can determine that we can determine the unit prices of each of the other products as such. I've listed the fractional answers and a rounded unit price for each of the 3 possibilities here. Thank you for listening, and I hope you have a great day.